6.3 is performing function operations and compositions, okay? What is a compound word when you have that in English? What does a compound word do in English?
It combines words.
It combines two words into one, right? Okay? So a composition is going to combine two functions into one. Okay? When you have functions, operations, remember that we can write functions as like f of x or g of x or h of x. We replace that y with that. It's saying the function of x equals this. Okay? If I have addition, I have something that says h of x equals f of x plus g of x. Here's what they're going to do. They're going to say f of x equals this. G of x equals this. Do that composition. Or do that function, okay? So if h of x is f of x plus g of x, and f of x is 5x, I sub that in for the f of x. If g of x is x plus 2, I sub that in for g of x, and then I simply add or subtract or multiply or divide, whatever it's asking me to do. So on your homework, in the instructions that you're going to have to read and pay attention to, the instructions that we don't pay attention to often, the instructions that are in bold black in your book, you need to pay attention to those because it's going to tell you what g of x is and what f of x is, and then you substitute them in and you do the equation. Okay? It's nothing new once I substitute it in. You know how to add 5x plus x plus 2. It's 6x plus 2. You add like terms. You know how to subtract 5x minus x minus 2. You combine like terms. 5x minus x is 4x, and I have negative 2. You know how to distribute 5x times x plus 2. 5x squared plus 10x. You know how to divide 5x over x plus 2. You would just leave it like that because there's nothing to do. Okay, because there's no rationalizing the denominator there. When you have division, however, you have to state your domain. How do you find domains of something? Does anyone know?
The Y.
No. Okay, the x. Domain is how far I travel on the x-axis. Range is how far I travel on the y-axis. Domain is this. Whatever is in your fraction, you take the bottom portion and you set it equal to 0 and you solve. So my domain would be x plus 2 equals 0, so x equals what? Negative 2. If x equals negative 2, my domain is all real numbers except negative 2. Because if I plug negative 2 into x, what happens to that denominator? You get 0. Can you have 0 as a denominator? No. So any number that I plug into x will work except for negative 2. So my domain is all real numbers except negative 2. What, Brady?
So you wouldn't have, so what about 5x?
Doesn't matter. I don't care about the numerator. I only care about the
Only the
denominator because the denominator cannot equal 0.
5.
Okay? So we're going to practice a bunch of
That's
these.
only for division?
That's
Or-
only for division.
Okay.
On multiplication, addition, your domain is probably all real numbers. The only time your domain is not all real numbers is if I'm dealing with radicals or fractions. Okay? So if it says, what's the domain of something that says 5x squared plus 12? You say all real numbers. Okay? So here, look, they give us some stuff. Now look, they threw in exponents because we're combining all the information we know into one big thing. And here it wants us to do f of x plus g of x. So what does that mean I'm doing? I'm adding, and I know that f of x is 4x to the 1/2, and I know that g of x is negative 9x to the 1/2. So I have 4x to the 1/2, okay, plus negative 9x to the 1/2. What does that give me? What's 4x to the 1/2? Minus 9x to the 1/2, because I can combine those because they have the same exponents.
Negative 5x.
Negative 5x to the 1/2. That's what we're doing. Okay? So adding shouldn't be a problem for you. Okay? Subtracting shouldn't be a problem, except you have to remember that if you have a double negative, you get a...
Blip.
Yes. Okay. So I'm gonna do the same thing here. I'm gonna say 4x to the 1/2 minus, I like to color code mine, you don't have to, 9x to the 1/2, okay? And what am I gonna get as my answer here?
13.
Yes, because I have a flip, so 13x to the 1/2. Okay? Now, on C, do you see where it says the domains of f plus g and the domains of f minus g? Okay? So my domain for f plus g is what? What can I plug into x? Can I plug anything into x and get an output? So what's my domain?
All real.
All real numbers. You can write it that way, okay? My domain of f minus g is what? What? What's my domain of f minus g? Stop.
All real numbers.
All real numbers also.
I didn't know what you were
Okay,
talking about.
because once again, I can plug anything in and get an output. The only time my domain changes is if I have a fraction or a radical in my equation. Okay, then I've got to think about what my domain really is. Otherwise, it's all real numbers. Okay?
So basically, it's
You can
just
put
like
ARN too if you want to, instead of writing all real numbers like that. ARN, you'll see that as your answer in your book.
So now, what do we do if we get two different, bottom numbers?
We're gonna talk about that in a little bit, but we're not gonna have two different bottom
That's
numbers.
what
You
I
would have a
thought.
fraction, or you would have a radical. Okay, so now let's talk about multiplication and let's talk about division, okay? Once again, f of x is 6x in this one, and g of x is x to the 3/4 in this one. So if I'm multiplying, I have 6x times x to the 3/4. Okay, can I multiply those together?
Wait, no.
Yes. Is it yes or is it no?
It's both.
It's both.
Because it's one x.
Yeah, because it's a 1 in
No,
front of that
both.
x. So what's with that red x?
A one.
A 1. So what do you do when you're multiplying? I multiply the leading coefficients together, so I multiply 6 times 1, which is
6.
Adam.
6, and then I do, yes.
Yeah.
So I have
Oh,
1
I
plus 3/4. So I get 6x to the what? Okay, they won't want you to write 1 3/4, they want you to write it how? It's gonna be an improper fraction, so what does it come out to be?
7/4.
Yeah, Mallory, 7/4.
How'd you do that?
That's not.
Because 1
4 over
is
4.
4 over 4.
Oh.
You have to change it to the same denominator, okay? So you get this,
Small.
6x to the 7/4. Does that make sense so far? Okay,
How did you get 6x though?
because this is 6 as your leading coefficient, and this is a 1 as your leading coefficient, so you multiply the leading coefficients together. Because
What
they
would it
have the
be?
same, they have the base is your x's,
Oh.
okay? Because that's what
Oh,
your
yeah.
exponent is with.
Okay.
Does that make sense?
Yeah.
Okay.
I was thinking of multiplying 6x times
Yeah.
x.
Yeah.
instead of-
Now I have f of x over g of x, so that means I have 6x, right? Divided by x to the 3/4. What do you do when you have that going on? You subtract, so I have 6 to the, or 6x to the 1 minus 3/4. What does that mean I get? 6x to the 1/4, yes? Okay, 1 minus 3/4 is 1/4. And that is my solution there. Now we have to talk about domains. Okay?
Stay in your domain.
Yeah, because it would be 4 over 4 minus 3 over 4. Okay. Now, domains. Domain of f of x times g of x. Let's talk about that. If I'm multiplying, what's my domain gonna be? think about this, I said, the only time you have to worry about domains is when what two scenarios happen? Fractions or radicals. Is multiplication a fraction or a radical? Okay, so the domain of f okay,
No, because it would still be all real numbers, because the final answer doesn't have a denominator.
that's what Mallory said.
Oh.
Okay, but listen, here's another way to take multiplication and division. If you figure out what the domain of each individual part is, I can figure out what the domain of the whole is. What's the domain of 6x? Can I plug anything into x and get a number out?
Yeah.
Yes, so it's all real numbers. What's the domain of x to the 3/4? What is another way I can write x to the 3/4?
Radical.
Yeah, the fourth root of x cubed, right? So what would be the domain of the fourth root of x cubed? That's the question, okay? So the domain of f consists of all real numbers. The domain of g consists of all, what type of numbers can't be inside of a fourth root? What? Negatives. Can negatives be inside of a cube root? Yes, they can.
Yeah.
Yes.
If it's an odd root, you can have negatives. If it's an even root, you can't. So this domain is all real numbers. This domain is any number that is not what?
Negative.
Negative. So I'm going to combine those two and take whichever one trumps it. Meaning, if this one is a stricter rule, I'm going to apply that rule. Okay? So this is all real numbers. This is all non-negative numbers. So what do you think my domain for f of x times g of x is then?
All non-negative.
Yes, all non-negative numbers. Okay, it's all non-negative real numbers. Okay, so when you have multiplication and division, you've got to look at each individually and then take the one that's more strict. That's the best way I can word that. Does that make sense? Okay, if I'm taking the domain of f of x over g of x. Now, you already told me f of x is all real numbers, right? And you already told me g of x is all non-negative real numbers. But now we also have another scenario because g of x is in a fraction on the bottom. Okay? And what can the bottom not equal? 0. Okay? So now we have to think, what would it come out to be? If I'm taking the fourth root of x cubed, okay? We're
You
on.
can't have negatives.
Oh, see.
You can't have a negative, okay? Now, on the top one, we said all non-negative real numbers, meaning 1, 2, 3, 4, 5, 6, okay? But if I'm taking the fourth root of something, can I take the fourth root of 3? No, there's not a fourth root of what type of numbers? Of odd numbers. So, okay, so my domain becomes a little bit more restricted. It's all positive real numbers.
What's the difference between non-negative and positive?
1 second, Mallory. Non-negative means 1, 2, 3, 4, 5. Positive real numbers means 2, 4, 6, 8, 10, 12.
So even numbers.
Yes. Ugh. It's rough, right? The way it's worded, okay? So you have to kind of like break that down and think a little bit differently. Listen, if you can identify domains on addition and subtraction, and just remember that it's always all real numbers, okay? We have done something well. A lot of people just struggle with that. If you can, on your homework, show me what the domain of this is and show me what the domain of that is separately, we're on the right path. okay? So if you can do them separately, we're doing great. If you can combine them, you're excellent. We will get to the combining part of it, like, it will come easier as we continue to do it, okay? But if you can do them individually for now, you're gonna get almost complete credit on your tests and quizzes, okay? So if you can label them individually for me, I can see where you like went wrong in your thinking when you put them together. Does that make sense? Okay. Okay. Ugh, I'll move this up. Okay. For white rhino, the heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms by these functions. So R of M equals 241 M to the negative 0.25. S of M equals 6 times 10 to the 6 times M to the 0.2. It wants us to find R of M times S of M. So what do I need to do if I'm finding R of M times S of M? What do you need to do? What does it mean when I say R of M times S of M?
You're
I
multiplying
multiply-
241
Yeah,
to the negative 0.25 times 6 times 10 to the 6th power
yes,
with a m to the 0.2 on the outside.
yes. Good, okay, so we set it up that way. Oops, I accidentally done it, didn't I? Gosh dang, it's doing, okay. Good, so we set it up this way. From setting it up that way, what do you think we do next? How can I simplify this, or what can I do? Think about this individually. This right here, 241, is being multiplied by the M, correct? This segment right here is being multiplied by the M. So can I take this and multiply it by this? Okay, so I'm gonna take 241 and this and multiply them together like this. 241 times 6 times 10 to the 6. What do I do with the M's? When you're multiplying exponents, you add. So then I have times M to the negative 0.25 plus 0.2, right? Okay? Yeah, so now I'm going to go ahead and distribute that 241 into the 6. What's 241 times 6?
I got y'all, don't do that, do it. 1,446.
Good. So I get 1446 times 10 to the 6th, right? And then I get, what's negative 0.25 plus 0.2?
No, you got 0.5.
-0.05.
Yes, negative 0.05.
Yeah, that's wild. We like that.
Okay, so I've got this going on so far, right? Okay, now, the only thing I have left to change is this, because it doesn't say solve for M, it just wants us to work this equation out. The only thing I have left to change is this. Why do I need to change this right here?
Because it's in,
Because it's in scientific notation, so what do I need to,
Between 1 and 10.
yes. So I need to move this decimal
2 places.
3.
Or
3 places, which
Okay.
changes that exponent to what?
10 to the 3.
9.
Or
10 to
wait.
the 9. You add 3 to
Absolutely.
6. There you go.
It's been so long.
So it's 1.446 times 10 to the 9th, and then M to the negative 0.05. And that's as far as they want us to take this, okay? Then it says, explain what this product represents. What does it represent?
White rhinoceros.
What does it represent?
Heartbeats.
The minute.
Beautiful. Heartbeats. It represents heartbeats. Because it says your heartbeat is your rate times your,
What was that?
okay? So that's taking composition of functions again. We combine two functions into one by multiplying. Okay?
Still got.
We do have a few more slides. Okay, now, that's adding, subtracting, dividing, multiplying functions. the next thing we're gonna talk about is taking a function and placing it in a function, like substituting a function into a function. Okay, just like you did substitution and elimination with 3 variables, now we're just gonna do them with a whole function. Okay? So, the domain of my input of f, okay, comes into my function f of x. And then I get g of f of x. So my domain of g, which is my input, and my output of f create my range of g. We're going to talk about it. I think it's easier when we look at it with real things. So if I have h of x equals g of f of x, this is considered a composition. Okay? When I have a function in a function. This is what it means. If I have f of x is 2x minus 7, and I have g of x is x squared plus 4, and I'm trying to figure out what g of f of 3 is. That means the first thing I need to do is take the function of g and put in the function of f anywhere there's an x. Okay? So g is this. G of x equals x squared plus 4, correct? Okay. When it has g of f, that means anywhere there is this x in the function of g, I am going to then replace this whole equation in for x. So, g of f of x equals this equation, 2x minus 7, and what am I doing with that? I am squaring it plus 4. So I placed that function into anywhere in the equation there's an x, because sometimes we have equations with more than just one x, correct? Okay, now, how do you do 2x minus 7? What do you have to do with that? If it's 2x minus 7 squared, what do I have to do? How many of them do I have? 2. So what do I do if I have 2? I have 2. Oil. Good job, Rita. So 2x times 2x is?
4x squared.
And 2x times negative 7.
Negative 14x.
And negative 7 times 2x. And negative 7 times negative 7.
39.
And then I have plus 4 out here, right? Now, I'm going to combine these like terms. So you get 4x squared minus 28x, right? And 49 plus 4 is 53. 53. Now, we aren't done because it said, what is g of f of 3? So what do you think I'm going to do with 3? Plug it into what? The x's. So I'm going to take 3, I'm going to plug it into these x's down here in this equation. Boom and boom. Okay? So then you get 4
Oh, you got a square first?
times 3 squared minus 28 times 3 plus 53. Yes?
Yeah.
What's 3 squared?
9.
What's 9 times 4?
36,
What's 28 times 3?
84.
Here we go.
Yeah.
Okay. Minus 84, and then plus 53. So, I have 36 minus 84 plus 53, and you get?
Quick math. I don't know. 5.
5. So, if I go back up here to the top of this page, is that a solution?
Oh, it's D.
D. Okay? Does that make sense? Okay? You're plugging an equation into an equation, and then you're plugging whatever the number they give you into that equation that you got. Okay? It's not hard, it takes time.
See, I like stuff like this. I didn't like the 6.2 stuff. That was.
Okay? It's not hard, it takes time. You've done all of this stuff. You've multiplied equations together before. You've multiplied and added like terms. You've done all of that.
I've done that.
This is just basic algebra. Okay?
Yeah, it is, 'cause I wasn't even paying
Ellie, why you
attention.
have
Now I
some more
understand
markers?
this.
Okay. let's do one more, and then we'll be
We
done.
have Jessica.
Why you snitching?
Stop, she's going out on service project, so she can wear that.
I knew she was.
Okay, f of x is 4x to the negative 1, g of x is 5x minus 2. Here's this, here's this. Okay, let's just set up all these equations first. If I want to set up f of g of x, what does that mean I'm doing? If I'm setting that up, it looks like this. What equation am I starting with?
The G.
The what?
The G one.
The 4x to the negative 1, because
What?
f is on the outside, it's saying f of g of x. So I'm taking this 4x to the negative 1. What am I doing with that? Plugging in the g of x to that spot there, right? So you end up getting 4, and then you get the g of x, which is 5x minus 2, and it's all to the negative 1.
Negative 1, what? Oh.
Okay, now from there, you have to think order of operations, right?
Ham dogs.
She wasn't getting there, is that right? So now you have order of operations. So I want to do parentheses first, correct? Okay,
20x.
so I get
minus
4, and then I get 5x to the negative 1, right? And then negative 2 to the negative 1? Because I gotta just, well, actually, if I have a power to a power, what do I do?
Put it on the bottom, just kidding.
I multiply. What power is with this x right here? 1, so 1 times negative 1 is, and then 1 times negative 1 is, so you get that, yes? Okay. Yeah. That's what we get, okay? Now, from there, Mallory told us we have to do something else, but before we do that, Mallory, what do I need to do next with that 4?
Distribute.
Multiply, distribute. So, 4 times this is what? And 4 times this is negative 8 to the negative 1. Now, what do I do from there?
Put it all over one.
Put it all over 1,
Under 1.
okay?
Under.
Put under 1?
Over one. I mean, no.
No,
Or
under
over.
1. Because you
Cause you're
got.
putting the one on top of it, right? You can't have.
You are correct, but here's the deal. If you do it this way, you're wrong.
Why?
Put 4 on top.
Or.
We can't distribute 4, okay? I kind of tricked you there on purpose.
Oh.
You cannot distribute 4. You have 5x to the negative 1 minus 2 to the negative 1. You have to flip that before you can do anything else. Order of operations. Exponents are first.
Hey, $10.
Wait,
Put it on the bottom.
wait, but we did.
Hey,
So you
Mom,
have
I sound-
4 over 5x minus 2.
Oh, wait.
Now, what's the domain of that function?
Dumb.
I don't understand this.
Is the function, what is the function at the end?
fraction.
A fraction. So, if it's a fraction, what does that mean I have to do?
Wait.
You have to plug something in.
You have to do what? I have to take the bottom and I have to set it equal to 0. If I take 5x minus 2 and set it equal to 0, you end up getting x equals 2/5, which means my domain is what?
All, everything but 2.
Yes, everything but 2/5. All real numbers except 2/5.
If it was a negative number, what would it
All real numbers except for that negative number. Okay, because it's not a radical, it's a fraction.
be? If it was a radical.
And then it depends what type of root you're taking. You can have negatives with odds, you can not have negatives with evens. So this domain is all real numbers except x equals 2/5. Okay? We're gonna stop there.